We're going to use this formula in yellow that I find easier to understand than what they teach you in class, and we'll be going through these two problems that my professor used to teach us the quotient rule in Engineering Calculus 1. So jumping right in, to take the derivative of a quotient, we need to use the quotient rule. Similar to the product rule, understanding how to define u and v is the hardest part. The rest is just about making sure you're careful with your derivatives and simplifying the answer that you come up with. All you have to know to define u and v is to view this formula where u is the numerator and v is the denominator, always. So we can define u as x squared plus 5 and v is x plus 2. Once we have that, we just derive both u and v and then plug and chug into this formula here. So du equals 2x and dv dx equals 1. So the formula in yellow tells us that dy dx equals du dx, which is 2x, times v, which is x plus 2, minus u, which is x squared plus 5, times dv dx, which is 1, and that's all over v squared, which is x plus 2 times x plus 2. So at this point, you just need to be careful with simplifying everything, make sure you don't mess up your distribution. So 2x squared plus 4x minus x squared plus 5 all over x squared plus 4x plus 4. And that is your answer to the derivative of x squared plus 5 divided by x plus 2. Moving to 1a, I threw in this bonus question because a common way the professors like to challenge you is to pose the question, find the equation of the tangent line to f of x at x equals 1 or at whatever x value they provide. So all you need to know here is don't let this trick you. You just need to understand that, like you learned in algebra, y equals mx plus b, where our job is to just define m and b, where m is the value you obtain when you plug in x equals 1 to the derivative that we just found, and then b is the value you get when you plug in x to the given f of x statement. So it's given that f of x equals x squared plus 5 over x plus 2, and then we just found previously that the derivative f prime of x equals this. So first we'll find m, which as defined above is f prime of 1, meaning you just plug in 1 to this statement every time you see an x. So m equals 2 times 1 squared plus 4 times 1 minus 1 squared plus 5 all over 1 squared plus 4 times 1 plus 4. And then that simplifies to 2 plus 4, which is 6, minus 1, which is 5, plus 5, which is 10, all over 1 plus 4, which is 9. Then we have b, which as defined above is f of 1, which just means we're plugging 1 into the given f of x, meaning that f of 1 is 1 squared plus 5 over 1 plus 2, 6 over 3, which equals 2. So then we plug that into our initial y equals mx plus b, which is the equation of the tangent line they're asking for, where y equals 10/9 x plus 2. Moving into question 2, we see we need to take the derivative of a quotient. So the first step is to define u and v, and then derive those two values. So as we noted before, u is the numerator and v is always the denominator. So we have u as x e to the x, and v is 3x to the 4th plus 1. So we can easily derive dv dx as 12x cubed. But when we go to derive du dx, we notice that the derivative is not so simple because it's a product of two terms containing x. So therefore we need to use the product rule to define this, which you'll remember from the previous video in this playlist, and please refer to that video if you need extra examples on that. But if we remember from the previous video, the product rule is defined as follows. So to take the derivative of x e to the x, we notice the first term is u, the second term is v. So u equals x, v equals e to the x. Du dx equals 1, dv dx, again, just equals e to the x. And then all together, we plug that in and find that dy dx equals x times dv dx plus v times du dx, which simplifies down to x e to the x plus e to the x. And then we plug this in up here. So it's kind of a derivative inside a derivative here. But once we define all those terms, then we can just plug it into the quotient rule formula. So du dx, we just found as x e to the x plus e to the x. We'll multiply that by v, which is 3x to the fourth plus 1, minus u, which is x e to the x, multiplied by dv dx, which is 12x cubed. And this is going to be all over v squared, 3x fourth plus 1 squared. So instead of simplifying all that, I think we can just leave our answer like this. So that's it for this video. If you understand those two problems that we went over today, I think you have the hang of how to define u and v, so the rest of the problem should just be plug and chug. Some key takeaways, though, are you have to make sure you remember to use the product rule if you ever are in a situation where you need to derive terms that are in the form of f of x equals u times v, where both of these terms have an x inside them. You need to make sure to use the product rule to derive that. And then if you ever see a problem where you need to find the tangent line, all that means is you need to find m and b, where m is f prime of the x value that's given, and b is f of the x value that's given. So other than that, I hope this was helpful, and I hope that you have one less problem to worry about on your exams. If you like this video, please like and subscribe so I can continue helping you crush your calc exams. Good luck, everybody, and see you next time.